Hi there, my name is Ron Rogers, and this video is about test flying the Airbus A330-200. Now, this test flight was conducted back in August of 1998, back when the airplane was still in flight test, and basically it's a shortened version of the A330-200. It's a shortened version of the 330-300. Now, you can see this was a long time ago because I still had blonde hair back there. I of course, turned into a platinum blonde, and I was chairman of the ALPA National New Aircraft Valuation and Certification Committee, although we may be called Airworthiness Performance Valuation Committee, which I was the director. They changed titles around. But anyway, because of this committee, I was able to get a flight on this aircraft, and I brought, of course, a couple other committee members along with me. I brought Captain Joe Kohler of Northwest and also First Officer Terry Lutz of Northwest. Both of these guys had extensive Airbus experience, and I was current on the Airbus A320. Now, Airbus, like Boeing, they've got a lot of different varieties. In fact, this isn't even all of the varieties. Boy, whatever flavor you want, distance, passenger load, stuff like that, they got one for you. Now, I was currently flying the 320, which is a mid-range, kind of a domestic airplane. It's not a long-haul aircraft like the 330. So there's differences there. There's differences in aircraft gross weight and seating height that you have to take into consideration. So part of this whole thing that Airbus prides itself on, and rightfully so, is the concept they call cross-crew qualification, the ability to move from one airplane to the other, because basically a lot of things are the same. They've got blue, green, yellow hydraulic systems. A lot of the cockpits, you almost wouldn't know which cockpit you're in unless you look kind of carefully and you paid attention to what you were looking at as you walked down the jetway. But anyway, I was current on, the A320, so my goal was to walk in the cockpit of the 330-200 and see how far I could get in the checklist before I got to a point where, something was a little strange and I didn't understand this or whatever. And basically, other than adding a few extra pumps and, fuel pumps and hydraulic pumps and things like that, it was a fairly similar aircraft. Now, one of Airbus's goals, and I've talked about this before, was design a crash-proof aircraft. They thought they could do it. Of course, that was a little bit of hubris there. And they were very arrogant about it in the beginning. Very arrogant, let me tell you. And if you question their philosophy or design, it was like you were spitting on the French flag. I mean, they were very protective of that. So it was kind of interesting in the beginning. They loosened up a little bit after these started crashing with greater frequency, and they got a little more of the humble pie. But at first, they were absolutely thought they had designed a crash-proof aircraft. Now, the 330-200, like I said, is a slightly shortened version of the 330-300. It's built for a typical range of 6,450 nautical miles with a 3-passenger configuration. Here are a couple of different seating arrangements there, and as you can notice, now that I'm retired, I'm in the back of the aircraft like I usually am instead of getting to be in the nice front part of it. But okay, the normal cruise for this aircraft is supposed to be 0.83 to 0.84, and the normal passenger load is around 381 passengers. It has an MMO of 0.86, so it's up there against kind of the limit of the cruise speed there. It's a high in regime, so of course you always have to worry about upsets when you're that close to the Mach limiting speed. Now, basically, the 330-200 is 193.5 feet long. It's 150. It's 15.3 feet shorter than the 330-300, so it's just a little bit shorter. It's 197.8 feet from wingtip to wingtip, and it's 58.7 feet high. So if you ever out in Denver and you want to go between the main terminal and Terminal A where they got that bridge, that becomes important because, can you make your tail under there? Most people avoid that just because you don't like taxiing under bridges. It's kind of a weird thing. Now, basically, I digress. Basically, the maximum takeoff gross weight of the 330-200 is 507,100 pounds, which of course is considerably heavier than the 320 that I was used to flying at the time. And here's a picture of the aircraft. And it's got two Pratt & Whitney's 4168 engines, and they give you 68,000 pounds of thrust each. All right, so here's the magazine article. Let's see, flying the airplane, it got on the cover, and we're down to, what is it, number 4 there. So we bounce around depending, I guess, where they fit us into the whole scheme of things. Now, one thing I also want to mention here is, well, Captain Wainwright was our host from Airbus. He was one of the new test pilots we hadn't flown with before. And one of the things we wanted to look at, and we were in the process of looking at, was, of course, all the factors related to aircraft fly-by-wire functionality. And I'm including my protections paper in this because one of the things we looked at was how the flight control interface worked with the controlled flight into terrain escape procedures. And one thing that I did in this whole thing is my airline that I retired from back when I was an Airbus captain, we were doing this research, it had a procedure that didn't take advantage of the protections afforded by the Airbus fly-by-wire system. And I used part of this research to go into my chief pilot there on the 320, and I say, hey, this is it. Here's my report. Here's the differences. And I'll show you these charts at the end, what I'm talking about. But basically, I said, you know, we need to do the what was actually the Airbus procedure. We need to follow their procedure, not our own procedure where we're trying to make it the same for everybody. This aircraft has a special capability. We should enjoy it. And we should not, well, you don't enjoy doing CFIT recovery procedures, but we should take advantage of it to the full capability of that flight control system because, you know, it might make a difference. And he looked at that and he says, you're right, we'll change it. And I go, okay, you know, because you're all ready to go with your counter arguments and all this stuff. And he goes, okay. And I go, what? It's okay, we'll do that. Well, that's interesting. Okay, into the article, and I've also included the article attached it here as a file that you can read all the little phrases I don't talk about and stuff like that. All right, so I basically got in the left seat, and of course, being committee chairman, that's one of the privileges, is you can determine who's going to fly, you know, appropriately, and I chose myself to do it, you know, but that wasn't necessarily the case. If there was a person on our committee who was a better person to put in that seat, first of all, I, of course, would put him in there, but we were all kind of equally capable in this. So I'm getting the left seat, and I'm going through all the steps, doing the checklist, programming it, and in the MCDU, the multifunction control unit there, you know, I'm programming it because, you know, I'm familiar with the basic Airbus aircraft, and I go through and turn on the overhead switches, extra hydraulic pump, extra fuel pump, stuff like that, and that's pretty straightforward. But when it came to actually programming the flight, I needed a little bit of help for one basic reason. First of all, I didn't fly out of Toulouse normally, and our procedure was to fly out of Toulouse and to land back at Toulouse. Now, as an airliner, you don't make a lot of money by like taking off out of Chicago and landing back at Chicago unless you're doing some really special, you know, flight. But anyway, so I needed a little help in how they did that. But the other interesting little thing on the throttles, we had visited earlier and made the suggestion that, you know, the throttle knobs are kind of small. And also we didn't kind of like the configuration of the reverser knobs. Now, originally, some of the engineers had the idea that you don't need throttles at all. Okay, way back in the beginning, Airbus was going to have like the old Edsel. You know, it had just push buttons. Like Edsel had push buttons for park and drive and stuff like that. Most of you probably don't remember the Edsel, but anyway. Basically, they were just going to have push buttons for climb and cruise and stuff like that, and no throttles whatsoever. And fortunately, Pierre Beau, one of the original test pilots, and he was unfortunately killed in accident investigation, got altitude sickness on a high altitude crash. And that's one interesting thing about test pilots. They will often assist, especially early on in accident investigations. And unfortunately for Pierre, you know, he died due to altitude sickness. And it was interesting. We came back and there was a room named after him now, and we thought that was, of course, very fitting. But one of the things Pierre goes is, no. You're not going to have push buttons and no throttles. you're going to have throttles, and you'll use just detents to signal, take a toga thrust, take off and go around thrust, climb thrust, stuff like that. He says we're not doing push buttons. So that's one thing he did. Now we commented that we felt the throttles were small, and we came back on this visit, and the throttles were actually larger. They heeded the comment of our committee and decided, yeah, those are a little bit small. Let's make them larger. So that was kind of interesting. And some other things we pointed out. An important change they did was there was guarding of certain hydraulic pump switches that were very close to the boost pump switches, because one previously, when they weren't guarded, had to make sure that you were getting your fingers on the right switch, because you could go up there and be punching around, late at night trying to do some fuel balancing, and there was an event where one pilot actually attempting to shut off some fuel pumps to do some balancing actually nearly shut off all the hydraulic pumps by mistake. So that is definitely not a good feature. Also, I noticed that the brakes when I taxied out were much improved. The A320 brakes I always felt had a little tendency to grab, and these were much smoother. And anybody who's flown an Airbus with that nose wheel steering there, that thing can be rather sensitive. And of course, I flew the 340 in flight test, and I had not been used to a big aircraft, and I tended to kind of over control that steering. Now, at the time I was flying this, on this test flight, I had flown the 319, the 320, the 321, the 330, and the 340. So I had experience in a wide range of the aircraft. When I first flew the 340, I was not used to a big, long aircraft, and I got a little carried away with the nose wheel steering there. That was more my fault than the airplane's fault, but it was just a rather interesting little aspect I notice. Basically, though, the interesting thing about the aircraft is, okay, it's heavier, and you've got the issues of being heavier, but basically, it still flies like a 320. It's got still the maximum roll rate of 15 degrees per second, and it just has the same various characteristics. Now, we flew the aircraft in degraded modes. We flew it in direct law and things like that. And the interesting thing about it that a lot of people don't realize, if you're in a reverted mode, normally in aircraft, you think of being in a reversionary mode, like if you're on one of the old Boeings and you're in you lose hydraulics and you're back into manual reversion where that's available. The aircraft is more sluggish. It takes a lot more control in this. Actually, this aircraft, the Airbus aircraft, because all of them meet the 15 degree per second roll rate, which is what they specify, so they all roll the same. To do that, you have to have a natural roll rate that is greater. So the natural roll rate on most of these aircraft is up around 30 degrees per second, and of course the flight control tailors it so you'll always get the 15 degrees, and to do that you have to have a higher roll rate. The other thing it does is the aggressive run-in function, if you will, tau, which is how fast the ailerons become effective. Anybody who's flown an F-104 knows that you can bang a guy's head against the canopy by putting in that aileron, because that is crisp. And okay, this is no 104, but it has very crisp roll response. And so I was kind of taken aback when I first flew it in direct law, and I had none of the flight control shaping that you get from the flight control computers. And I got the very steep rise on the input of the aileron, and I'm going, this thing flies, better, if you will, a faster roll rate in reversionary laws than the normal. So that was kind of funny, because you don't really you think about doing that. Now, as I said, you can read about this in the report if you download it. We did a number of stalls in that, and Airbus was a little more concerned about how deep we went into the stall than Boeing kind of was. had been. But any large transport aircraft like this, you have to be very careful. The aircraft is all instrumented. You get disturbed airflow off the wings during a stall, and that can impact the horizontal stabilizer, and you can have significant loads imposed on it. And you don't want to get into any structural problems. Having the tail separate during flight test is a very bad, usually non-repeatable event. So you don't want to go anywhere near that. So that's okay. You know what you want to do with your aircraft. We're fine within your limitations. Now, I have a flight test guide that I present and say, this is what we'd like to do. And then we negotiate on, well, you can't really do that. We don't want to do spins in transport aircraft. No, I never put that on there. That'd be ridiculous because it won't come out. But anyway, one thing you do want to be careful, though, in any large swept wing transport aircraft is you basically don't use the rudder because you can get out of phase with the thing. And like I mentioned on one of the early 777 flight evaluations, a different pilot, not in our group, got aggressive on the rudder, and actually they ended up rolling 90 degrees during the stall, which John Cashman, who was the chief test pilot on that, says was rather interesting, and I can imagine it would be. Now, one thing I'd like to comment on flying this aircraft is that it's got a dual bogie gear system, and that gear really hangs down. So when you come into the flare, and we felt these struts were a little kind of stiff, it was hard to get as nice landings as we had hoped. We'll blame it on the struts, right? Always have something to blame your landings on. But anyway, you touch down on that rear bogie, and then you go through a very significant derotation of the nose before that front bogie comes down. And when the front bogie comes down, the first time I experienced that on one of the other flight tests earlier, I thought that was my nose gear. Well, I still had 5 feet to go, and I relaxed on the stick, and boom, it came down. So that kind of got my attention. So basically, there's kind of a 3-point landing. The rear bogies derotate front bogies, and then continue to fly down the nose to bring the nose smoothly onto the runway. Because of course, you don't want to tick off the people in the expensive seats, and that's if you bang the nose gear on. Oh, one other thing I'd like to mention: we did a lot of stuff in direct law on that. One thing I'd like to mention about direct law is even the pitch was more sensitive, and we had just a little tendency to bobble the nose, as you will, because of we didn't have the nice features of the fly-by-wire flight control system. Now, one thing I commented to Captain Wainwright that was I felt that the aircraft was rather unresponsive in the pattern. I could stir the stick and not get much of a response at all. And I said I'd kind of like a little crisper response. And then we got into a discussion about the roll rate, and to get a little more response, you'd like a higher roll rate. And they had looked at 20 degrees per second, and actually part of this committee work, it is drudgery. It's terrible. We got to eat in all the fine restaurants in Toulouse, and we, French wine. French do okay with wine, right? Yeah, of course they do. They do excellent wine. And after a few glasses and a few bottles, you get talking with the test pilots and, in Vino Veritas, and found out that, they first looked at 20-degree roll rate because that's a respectable roll rate for an aircraft. And they found out that at 20 degrees, you could excite a PIO. Now, they don't call it PIOs anymore. That pilot-induced oscillation. That makes pilots sound bad. They call it aircraft pilot coupling, APC. It's an issue with aircraft pilot coupling that the two of you aren't getting along very well, okay? And they found out with that extra 5 degrees that you could get, and they did, it occurred on an Airbus 320 in a landing situation where you got a pretty good, almost 60-degree bank-to-bank PIO APC situation. They said that's not a good thing, obviously. So they backed it off to 15 degrees, and that kind of solved that problem. Now, like I said, you can read about it in the articles. I flew a number of patterns. I flew a single engine pattern. We did V1 cuts, and like I've always said, the aircraft always fly so much better than the simulators. They fly nicely. They're very controllable and stuff like that. And of course, the Airbus has a lot of features that help you out on engine failure and stuff like that. In fact, one of the first demonstrations on the 320, the Pierre Beau pulled an engine back. We took off, And he says, take your hands off, your feet off, and he pulled an engine back. The airplane just goes into a 5-degree bank and continues to climb, and it's very controllable. You're not going to roll over and die like you might in my Cessna 310 if you tried to do something like that. But anyway, I did some single engine patterns, and I landed and did the test where you do one reverser. Now we had, it was a dry runway, so we had good braking, good nose wheel steering. It wasn't like we were landing on slush. So, I could go reverse all the way down to 80 knots and had, very good control. And the one thing that I can mention about flying this aircraft is that, yeah, they met their goal, where they can operate. You can easily change between one aircraft and the other with minimal retraining. It's just some differences and stuff like that. In fact, Lufthansa for a while tried flying 340s and 320s together, which was, it's not a bad idea. You fly your long haul stuff where you don't get a whole lot of landings. It can be hard, especially for co-pilots, to keep landing currency. So you could fly the 340, and then you go fly the 320 where you fly domestically and you get a whole bunch of landings. So you keep a nice degree of currency there. But anyway, it was like typical Airbus. They did a beautiful job, and from this whole flight test thing, it's fun to fly a brand new airplane. Now, let me tell you a little bit about some of the controlled flight into terrain test we did. We did first of all. Here's some stuff on the that we got from the 330, and I want to thank Airbus and Boeing. Boeing was a different company back then, let me tell you. But I want to thank both Airbus and Boeing for the data handling, data process they did. Fernando was very Fernando Alonso was very helpful in this. I mean, he was the head of flight test engineering there. He was flight test engineer, and he became the head of it. Very great guy, very cooperative, and basically the controlled flight into terrain procedure, at least for most airlines at the time, was to smoothly rotate to 15 degrees and a smooth rotation rate of 3 degrees per second. Well, at least and especially for the Airbus aircraft, the CFIT recovery procedure was very simple. You pull the stick straight back. You just pull the thing straight back, and you can shove the throttles full forward, but they'll come full forward anyway if you pull the stick back, because you'll start to get out for protection. So, okay, there, unless you're less than 100 feet, stuff like that. But anyway, you pull the stick full back, you go full on the throttles, and you'll get about a 6 degree per second pitch rate, which gives you, as you can see on the graphs, a lot better CFIT recovery performance on, we had flaps full gear down, and we had gear and flaps up. So we were looking at a couple of different configurations here. Now, we also did it on the 777-300. We didn't have a 200 available at the time. They were into the 300 flight test program, and that was available, so we did that. The only interesting thing I want to point out here is that when we use the higher rotation rate, we actually sunk 17 feet lower. And I kind of attribute that to the fact that the engines weren't, the engines take a while to spool up. So we weren't getting the full thrust, but yet we were putting on a ton of drag, and we were essentially sinking. When you did it the slower rate, you didn't go down as far, okay? But overall, you got a better performance, and I also contributed to changing the CFIT recovery procedure in the 777 also at our fleet. So I changed due to this data we had taken basically two CFIT recovery procedures at our airline on two different aircraft. This paper, and I mentioned this earlier, I got Best Technical Paper of the Year award from the Society of Experimental Test Pilots back in '99, and also designated as an Aviation Week Space Technology Commercial Aircraft Laurels winner. And here is, I couldn't get both these graphs on the same page here. Here is with the gear and flaps up. There, because you still had spent plenty of smash going because you were going faster. You had plenty of airspeed. You didn't see the degradation of the altitude during the recovery, but still, basically, you pitched at a higher rate coming up to the pitch PLI, the pitch limit indicator. It brings you up to about 17.5 degrees or so, and it keeps you out of stalling it, because on the 777 you can bring it right back, almost to the stall. You can actually pull it into the stall if you wanted to. Actually looked at that, but it was like 135 pounds of force. So when you're just getting into the G onset, it's about 90 pounds of thrust. So the aircraft is telling you, if you want to do this, fella or lady, you got to really pull, and you're going to have to pull hard, because it's going to take a lot of force to get this little sucker coming back. And I have no idea why I'm getting that thumbs up in the side. It has something to do with, I'm not going to mention the name of, Alicia or whatever. But anyway, that's the story of that research, and it's an appendix to the discussion of the general fly-by-wire flight control aspects of the aircraft. So there's what the airplane looks like on the underside if you're laying out at the end of the runway watching airplanes go over. But anyway, it was a very interesting flight test. Long time ago, we had a fun time, and I have no idea what the committee's doing now. I had the most fantastic group of people on my committee, and we did some great things, and that's kind of, unfortunately, as far as I know, gone by the wayside, and the committee doesn't have any significant presence as such. But anyway, not that I'm aware of. So, hey, enough complaining there. Thanks for watching. I hope you enjoyed it.